I would like to introduce Nell to give our first presentation of the night.
Yeah, hello, welcome, hi, I'm Nell. Hope everyone here is having a great time. Welcome to my very first talk where I think something is wrong with game engines. Let's go. Oh God. So this presentation is about game engines, of course, and also reducing the, but actually mostly reducing the complexity caused by game engines. I will not be covering things like Unity-like pricing plans as much as people like dunking on that, or game design, or low-level programming. That's something I really like to talk about, but I would like to appeal to a larger audience, so I'm not doing that today. Oh. So, quick introduction. I'm a graduate from BCIT Electronics, of all things, and now I'm somehow a software engineer at a cloud telecommunications company, and I just happen to have a lot of random computer-related hobbies. If you take programming, digital art, music, you put them all together, you just get game dev, so it's kind of inevitable. And I've been doing this stuff since I was like 10, so it's over a decade ago, but yeah, my favorite games are Ace Combat, Kerbal Space Program, and this one called Sulfur Nimbus. And it's not like a surprise that all of these have to do with flying. I really like flying things, as long as they don't interrupt the presentation. But yeah, so do I make games? So yeah, of course. Well, a lot of my games are programming focused, and recently I've only been making games for game jams, because I'd rather work on one big project than a lot of small projects. This one's like my latest one, which is like some kind of factory tower defense. You got some particularly infamous ones. There's also mods for other games, like Lethal Company mods and Kerbal Space Program mods. And also, yeah, of course, game engines. My first serious game engine was like a high school project I made back in 2014. It uses the exact same guts as Minecraft Java Edition does, but it uses Java and LWJGL. My idea was that you can write games in JavaScript and then run them in Java. I think that was a horrible, at least for the time I thought it was a great idea. Now I think it's a horrible idea. You know, I've partially recoded the thing in C++, and now I've abandoned the project. You know, it has basic features. The compositor is pretty cool, but it's not that good, but I'd say it's pretty cool for a 14-year-old to have put that together. Okay. So, but first off, what is a game engine? But first, like, what is the game engine not? Like, first, programming languages, frameworks, not for games. Those aren't really program language. Emulators, you can kind of argue it's a game engine, but it's not. And things that are likely game engines are software that runs games, of course. Or sometimes just technical code that's in a game. You'd hear some people say stuff like the Minecraft engine or the Starbound engine, even though that's not really reused across different games. Or like, it's an engine if the developer says so. Like, I can take a web browser, I can rename it to something engine. I rename it Condion 2, and done. It's a game engine. It has inputs, it has sound, it has graphics. Game engine. So common game engine features are just some platform abstractions, window input. They're all like, every game engine's roughly kind of the same, but maybe some have 2D or 3D features, something. But the thing I'm going to talk about the most here is the object system. And that is how every game engine seems to use some kind of object world to represent, the entire game. Like in Godot, you use nodes, and there's many different kinds of nodes, and you can make. Actually, no one actually makes custom nodes in C++, ignore that. But Unity, you have a bunch of game objects, and you add components to these game objects. You have a special component called monobehavior that you can add scripts to it to make your game do things. Unreal, I never actually used Unreal. I'm just like putting what I saw off the wiki. But yeah, they call them actors, and you put a tree of components into them. It makes your actors do things. And there's also blueprints that just make writing actors a lot easier. So in general, to make a game, you make a bunch of objects, and then you just add stuff to them, and the game will do stuff. So as an example, let's make a chess game. I don't need to explain the rules, because I'm sure like mostly everyone has kind of at least played it once in their lifetime. So you just have to create a new project, add game objects, and then add sprites, and add an on-click event. So if you click the chess pieces, it'll show all the possible moves and things, right? But very quickly, we'd probably just hit a brick wall. Like, we think we're doing a lot of progress, and then suddenly everything becomes extraordinarily difficult. Like, how do we actually calculate all the possible moves? How do you put the game objects in a square grid? And how do we avoid putting ugly global variables everywhere? And I'd say this is the sign of a lot of underlying issues. So what went wrong is that every chess move actually involves the entire board, right? Like in this example, for this bishop can't actually move here because that would put its king in danger of this rook. So the behavior of everything in the board has to be considered to just move one thing. So we can't actually, it's kind of impractical to put code into that chess piece object. So, and also we really need objects. Like game objects try to be this one-size-fits-all problem. You know, one size fits all, and I think that's a bad thing. And also code is unavoidable. Like even if your game engine has like drag and drop features and things, it's still gonna be code. All in the end, it's still like, it's actually code, but just looks more friendly to some people. So chess the easier way. Every game can actually, like every game, not just chess, every game can be represented with regular variables and data and things. So you can get chess. Chess is just like a big 8x8 array of squares, right? There's 64 squares, and each square can be one of 6 pieces with a team color. So there's 12 possible states. You can do this with a single byte at minimum, because like a number between 0 to 12, or 2 numbers, who knows. But also various kinds of stuff. I'll get to these in a moment. And also, we don't need to rely on a game engine. We can write all this in a regular programming language and make it extraordinarily fast and optimizable. This is actually a Wikipedia article about how to make this thing extraordinarily fast. And yeah, this is actually real. So if I go ahead and run this, make sure it's standard. Yeah, that's, I was actually rushing this while in transit on the way here. So as you notice, like, the screen is resizable. And it's kind of running, it just kind of doesn't have an engine in it. I'll get to the code. But like, yeah, we got, there's no turns yet, I know. But everything kind of roughly works. And if I look into the code, oh God, code, just slightly to the left. So yeah, here we have square. Square can be a piece. Piece can be a none, a rook. No, that's a pawn. It can be nothing. It can be pawn, rook, knight, bishop. So we got piece. We got player color. I decided to just use 2 different values here. And somewhere down here is the board, which is just an array of squares, 8x8 array of squares. And if the code that actually draws the board to the screen is straight up like, how does it go? Yeah, well, this is the user interface. Like, no, you don't need any CSS. Just calculate all the spacing between everything and just, 5 lines of code or something. And then drawing the chess game. There we go. It's a function called draw chess game, where I just draw the chess game. Go through a for loop, 8x8. Just 2 for loops. One to go to iterate each row, and then one to go for each other row, and then draw the chess piece from there. And I'm using a library called raylib here to make all this possible, which is kind of not an engine. So that's that. And also, like, so chess is like a turn-based game where everything has to be synchronous and all. But how about like a real-time action game, like a first-person shooter, or just, a flight simulator maybe? But so the thing here is that game engines always provide some kind of update method, update step or process, depending on which engine you use. It's the same thing, but they call it a different thing. And the thing I have a problem with this is that values can be modified anywhere, anytime, from any place. So, and I think that's highly, highly, highly bug prone. So in this example, I have a blue ship and a red ship. And objective here is to make the 2 objects be able to move, but also look at each other, aim at each other. And don't include bugs, no bugs. This is really helpful advice. So we add an onUpdate script on, which is function, event, same thing. Where, they calculate a new position, and then they look at the opponent. So blue looks at red, and then red looks at blue. Is there a bug here? Is there a bug? Yeah, of course, there's a bug. Yeah, and of course, what happens here is that the blue is going to end up looking at the red's previous position, because when blue updates, red hasn't updated yet. You see, red hasn't moved yet, and blue is already aiming. What happened? Like, that's not good. So what we actually want is we want both of them to move first, and then both of them aim afterwards. So what we should actually be doing is have a single script somewhere higher up that can control both objects from below. And this can be like a world update function provided, maybe the game engine provides that, hopefully. But this will help kind of like separate the code from the objects. And if there's more than 2 objects, let's use a for loop for similar issues. So those issues exist. So should we stop using game engines? No. It's very, very difficult to switch. There's a rich ecosystem. You know, the game engine has a rich ecosystem, lots of useful features. And just use less scripts. That's really it. Just use less scripts, maybe call them services to control multiple things below it. And there's also this trendy thing called entity component system. Might be worth Google searching, but that's for further reading. That's actually like 50 other 1-hour presentations. And also, no engine, no problem. If you write your game with no engine, you can actually use it across different engines. Like, you know, if I write it in C++, I can just throw it into any other C++ engine. Like, I can make like an inventory system or an item system. Well, that's the same thing. And just use them across 30 different games with different engines in them. And we'll be limited by the language, not the engine. And yeah, of course, I've been saying C and C++ a lot, but like, hey, I use Rust too. Yeah, so and like in this picture, I have a game that runs on 48 megahertz microcontroller, but also runs on a desktop. And some engine recommendations: Raylib, Louvre, and just a regular old HTML5 canvas. And yeah, my evil plan, like why am I so like deep into game engines? So it's like I've been working on this like space flight simulator, and you know it's going to be extraordinary. It kind of has to be really complex. It's literally rocket science, right? And it's going to be spacecraft with interconnected parts. You get like universe scale planets, and it needs this custom engine. And I want it to be multi-threadable and fast. And I've rewritten it too many times. And yeah, there was like a small development team, but I'm kind of the main developer of this. And yeah, this is like me like rewrite this is the GitHub pull. This is a GitHub pull request where I've completely gutted a single subsystem that involves completely deleting very large portions multiple times. Yeah. So yeah, thanks for listening. And any questions? Is there another mic?
Project.
All right. Well, just a great presentation. In terms of like when developing a game, and you know, as it grows, like you know, with GitHub, for example, how do you like you know maintain you know space and size, and then at the same time, say make sure that you're integrating the right plugins and tools within, say, an engine to make sure that you know it stays together. Because like recently I was on a project where they had to do it in C++ with Unreal, and the plugins kept on like needing to be rebuilt all the time. So it's like there's got to be a way to optimize that engine rebuilding as well as just the overall game functionality.
Right. Yeah, so there was the option of like having the engine as like a separate shared library, so you don't have to like build it all the time. And also just get general programming issues. Like it's not special to game dev. Like all programming, all software development shares the same issue of how do we organize a humongous code base. There's entire software, this entire job positions on doing that. Right.
Let's say you have like 30 game objects, each with their own behaviors and scripts. Do you have like tips how to make them like cross-operable with each other?
Yeah, just you write a function that takes in both object A, object B, and then does something to them. Like a single function to just takes in both objects, so you can modify to both. Like
you can does it scale to like hundreds?
Yeah, it's regular functions. Like it's you can do functional programming and stuff. People say that scales. So like.
So I noticed you said, and you kind of brushed over, and I agree with your talk. I thought it was really interesting. You did brush over entity component systems and Bay and Rust and otherwise. But isn't that the answer that you're looking for?
It's because in that open space program project I mentioned, I was doing entity component system, but then realized like, why does everything need to be an entity? And I'm just running into all the same problems that I had with typical objects. So it's just like, what it turns out. Like it's just having there's lots of different kinds of entities, so it's just, and they're stored in different places across different modules or components. They're not really names for any of these. But I kind of got beyond entity component system, and entity component system has kind of conflicting interpretations on what it actually is. So.
I have a question. Have you tried the game Star Citizen? Your idea is very good. Everybody, I feel like, in the end game thinks it's to do an endless universe. Have you seen Star Citizen?
I haven't seen Star Citizen, but I've considered having like a 24/7 server of like a solar system or something that, you know, like a real-time space mission. That's kind of a niche thing, because space missions take like months to complete. You can launch something, wait like 10 years, and then land somewhere. So gameplay-wise, we're gonna have to make an extraordinarily unrealistic space flight simulator, or just find a way to do time warping with everyone else. But there's some Kerbal Space Program mods that are actually able to do that. So yeah, I think that's the last question, is it? Yeah. Right, thank you.